Now basic physics. In this lecture we see the solution of NCERT class 11 4.20 sum. Problem 4.20, 4th chapter, 20th question. So we see how to solve this sum. We took up vectors. You are seeing a lot of examples by way of explaining the concepts. So now we take up this because this comes under vectors. Motion in a plane, it comes under motion in a plane. We just see how to do this sum. Okay, I first read out this question. The position of a particle is given by r is equal to 3.0 t I cap minus 2.0 t squared j cap plus 4.0 k cap in meters, where t is in seconds and the coefficients are the proper units for r to be in meters. Subdivision A, find the velocity vector and acceleration of the particle. Subdivision B, what is the magnitude and direction of velocity of the particle at time t equal to 20 seconds. This is application of vectors. R is equal to 3.0 t I cap minus 2.0 t squared j cap plus 4.0 k cap meters. T in seconds and other are in proper units. Other things are in proper units. Suppose to find velocity and acceleration in the form of vectors. So V is equal to dr by dt. See here, calculus is also there, vectors is also there. Vector concept should also be applied. Differentiation also should be done here. Dr by dt, t is there, so just 3 I cap minus t square is there, you know, x power n is n into x power n minus 1. So 4 t j cap. This being constant, it will not be there. Similarly, acceleration, you will have to differentiate this once again. This is constant. How do you know whether it is constant? Because there is no t in this term. Here also there is no t in this term. That means it is not dependent on time. Therefore, you treat this term as a constant. Now this is not having any t, so this is to be treated as constant. Therefore, it will be 0 when you differentiate this. Minus 4 t alone is there, so minus 4 j cap. That is acceleration. So the answer is simple. Velocity vector 3.0 I cap minus 4.0 t j cap. Acceleration is minus 4.0 j cap. You got the acceleration and velocity vectors. Now he is asking you to calculate the magnitude of the velocity vector. So magnitude of the velocity vector, root of magnitude of the velocity vector at some time t, when time t is 2 seconds. Okay, magnitude of the velocity vector at time t equal to 2 seconds. At 2 seconds. So velocity, this is a vector expression. So velocity when time t is 2 seconds means 30 I cap minus 8 j cap. So magnitude will be root of 3 square plus 8 square. Because t is 2, you know. So this is root of 9 plus 64, which will be root of 73. This is magnitude, which will be root 73. 8.54 meter per second. 8.54 meter per second. And the angle is asked. Angle, you can say what angle it makes with either x-axis or y-axis. Let's say we will do it for x-axis. You know that tan alpha is y by x. That is easy. Tan alpha is y by x. Suppose if it is v vector alpha, tan alpha will be vy by vx actually. So so tan alpha is vy by vx. That is y component of the velocity divided by x component of the velocity. What is y component of the velocity? That is tan alpha is minus 8 by 3. So tan alpha is minus 8 by 3. So find alpha from that. Tan inverse of minus 69.4 degrees. That means 69.4 degrees down the x-axis. Minus symbol is there, you know. Suppose if it is x-axis, this is the velocity vector at time t is equal to 2 seconds, 64.4 degrees. Understood that? Okay, thank you.